Having seen the intuition and an illustration on how this variable length, let's say sliding window works to solve the problem of finding the shortest subarray adding to a given target, now it's time to focus on the code. As we've discussed before, moving from intuition or illustration to code is always to be done carefully, because if you are sloppy, if you're not careful, mistakes can creep in and they can be a bit hard to debug. In fact, in this particular case, the code itself is a bit tricky because the pointers are moving somewhat unrelated to each other. Basically, the pointers are moving with very clear rules, as we saw earlier, but they're not moving together. Sometimes the right one moves, sometimes the left moves, and that can cause, let's say, a little bit difficulty in writing the code. So there are at least two approaches we can use for this code. My preference is the one that I'm going to do first, which is a single while loop. So basically, this is kind of like the illustration is. On every iteration, the window either expands or contracts, which means either the left pointer moves or the right pointer moves. And this happens on every iteration, which is somewhat more explicit to understand. The second approach, which seems more popular in the literature, is to use two loops, a for loop for the right pointer, which is an outer loop, and then an inner while loop to move the left pointer. The net effect is the same. In this approach, is the outer loop expands the window, inner loop contracts the window. So the principle remains the same. But my preference in terms of, let's say, clarity of the movement is actually the first one. So that's what we're going to look at first. Basically, the idea would be to create, let's say, the two pointer situation. We know we will run a while loop, single while loop, while right is less than n. Now this is quite interesting. We'll see that, even though right will touch the last item, but loop won't stop. The reason is, basically on every iteration, we are either increasing the right or increasing the left. So it means we are either expanding the window or contracting the window. Right is keeping track of what is being added to the window. So that's what I'm doing. I'm adding to the current sum. If I find the current sum is less than or equal to target, remember, less than or equal to target, I just find out if I have found a minimum window. So that's this portion. And then I expand the window. Now there's one more condition here, left equals to right. We'll talk about this a bit later. And then on the other hand, if I find that, look, current sum is greater than the target, that's my time to contract the window. I do that by removing the left item. And then, again, you see this statement here. We'll talk about this also a little bit later. But interestingly and expectedly, at this point, we contract the window. So this code, like I said, is a little bit tricky. Let's write this slowly and try to understand its working, and then also get into some of these more detailed points so that we can understand this very clearly. So I get here to my code and I write, for example, define shortest, say, sub array, given a list and a target. So find the shortest sub array that adds up to target. So let's say given a list L. Okay, I've had list L. Find the shortest sub array adding up to P. So that's the problem statement, that we are solving here. So I define a few variables here. So for example, n is length of the list. Convenient to have it in this form. I define my two pointers, left and right. Remember, I set them to 0 and 0 to start with. I define a variable to keep track of the present window sum. So let's call it current sum, and I set that to 0. I define the minimum. So basically I'm looking for the shortest range. So I just go and say, well, look for range min. And let's say, where does it come? So that's my left min, and I'm going to assign these to, say, float inf. Look, I'm looking for the minimum, so I assign this to a large positive value, and the left min, I just set it to 0. Now remember, my code is going to run while right is less than n, because right really cannot go beyond, let's say, the last item on the list, which is n minus 1. Now when I get into the loop, basically I update my window by saying, well, current sum is current sum plus whatever is coming on the right. Now think about it. In the very first iteration, basically left is 0, right is 0. I will go and update the first item of the list into the current sum, which is exactly what I should be doing. Because remember, it's kind of like the first item is now entering the window, and hence I'm adding that. So I'll do that. Now, this is where I check, I ask a question. Look, if my current sum is less than or equal to target, or, now we will talk about this in a moment, left is equal to right. This condition is actually quite vital. We will speak about this, but we do need this. If current sum is less than equal to target or left is equal to right, well, I ask myself, is my current sum equal to target? Because if it is indeed equal to target, then I found a window that meets my criteria. So I just go and say if cur sum is equal to target, and I find that right minus left plus 1. Now, why are we doing this? Well, remember, the pointers are right and left. The window length is right minus left plus 1. The most, let's say, easiest way to sort of visualize this is when both right and left are equal, I'm looking at one item, hence the window length is 1. If right is, let's say, 2, left is 1, well, I'm looking at two items, and hence right minus left plus 1. So very clear that this is the length of the window. If this is less than range min, so if I find that, look, I found my target, and indeed if it is less than the previously found, let's say, range, I will have to update my range min and also the left min. So I know I found a new, let's say, subarray which adds up to the target. My range min will be right minus left plus 1, because this is a new range which works at this, and my left min will be equal to the left, right? Because remember, this is where the window is starting. Now, very interesting, think about it. For example, in the beginning, if left is 0, if I do not move the left at all, window is actually starting at 0, and likewise, right? So it's always left is where this is starting, and hence I record left as my left min. Now, having done this, remember, this is a situation where current sum is less than equal to target. I just go and say, well, my right pointer must move, and hence I make it right is plus equals to 1. Else, I see that, look, my current sum is becoming more than the target. Notice this is less than equal to, which means the only time I come in here is when I'm more than the. Well, it's time for me to move my left pointer inwards, and the way we will do that is we'll take the contribution of the leftmost guy out from the current sum. So I will do cur sum minus equals to, let's say, L left, right? So basically the contribution of the leftmost guy has been taken out. Now, in this situation, I'm going to move my left pointer outwards, because remember, this is contraction of the window. But before this, I need to do something which may sound a little counterintuitive. Remember, in this situation, my right pointer really hasn't moved, because this is an if else. So if I found that the current sum is more than the target, my right pointer has stayed put wherever it was, which means that if I don't do anything, when the loop runs back again, my current sum will again add the L right to itself, right? So that's going to basically count right item twice, and that's not correct, right? So in order to sort of preempt that, account for this, I'm going to say cur sum, is l- let's say minus equals to L right. Now this is, like I said, is a bit counterintuitive, but it's just the way the code is set, because this will anyway get added again, right? So I'm just going to say, since this will be added back. I mean, the point is, in each iteration, either the left is increasing or the right is increasing. And if we are in this else situation, well, the right is not increasing, it's the left that is increasing. Hence, I do not want a double counting on the right when I come back to, let's say, this line here, right? So I just preempt that situation. And with this, in fact, we are done. I can, at the end of this, let's say, the while loop, I can return, range min, and also I can return the left min. Now, before running this code, why is it that I have put, let's say, this condition over here? Now, the reason I put this, remember, is because if my left and right are pointing on each other, this will happen if, let's say, a single item is actually exactly equal to target. So my left will go and sit right on the right. Now, if this happens, come what may, I'm only increasing the right pointer, because remember, I put a condition that no matter what happens, my left will never exceed right, because that's a weird situation to handle, and I don't need that at all, right? So if this is the situation, come what may, I'm only going to make my right move. And if you think about it, when the code first starts, which means here, in fact, we have the same situation. Even if this number was 8, or even if this number was 20, whatever it was, I'm only going to increase the right, because that is the logical thing to do. So, very interesting this point is that if the two pointers are equal, I'm going to increase the right only. And that is why I have put this condition. Now, in order to sort of, understand this code working, let's, run this code with, let's say, a little bit of an example. Now, in order to, let's say, understand the working of this code, I'm pushing the same list that I've shown the illustration for, and also I'm printing here the values of the current sum, the left and the right. So left pointer, right pointer, and current sum. So that way we can understand how this whole thing is working. When I run this, basically the code runs, and I get the movements as we had seen before. So I start at 0 0. My sum is 1 because remember my first item is 1. So maybe I'll just make this a bit smaller. Yeah. So I start at 0 0. Sum is 1. Sum is smaller than the target. So I expand. I move the right pointer out. Sum becomes 4. I still expand. I still expand. I come until 0 4 11, which means I'm looking at this entire row 0 1 2 3 4. That sum is 11. Time for me to contract the window, and indeed that's what I did. So left goes up, it becomes 10, it becomes 8 over here. I of course note down that this is 8, this is 2 5, which is 0 1 2. So 2 1 4 1. This is this is the window we are looking at. The code goes on now. Very, very interesting. Once I reach the end of the list, right? So I keep going, just like we saw in our illustration earlier. I have reached the point where my right is in fact equal to the n minus 1. So that's basically this point. So I've reached 0 1 2 3 4 5 6 7 8 9 10. My right is here, but notice the code immediately does not stop there. Once again, that is because remember, it's either the right increasing or the left increasing. In this case, when I get to this point, in fact my sum is more than the target, which means for several iterations thereafter the left keeps increasing, and you can see that clearly. It becomes 5 6 5 7, sorry, 5 6 7. At this point it is 6. The only way I can move forward is to have my right increase. The right increases, but then this while loop comes into play and the loop terminates. So very, very, very beautiful. Putting these prints here makes this very clear. Think about it. Before I wrap up, let me just once again highlight the key points of this code, which I'm happy to discuss. So like I said, some key points here. In every iteration, we are either increasing the left pointer or the right pointer. In fact, that's what I like about this while loop implementation. Very explicit what's going on. Is the right increasing or the left increasing? And if so, why and how? When we increase the right pointer, the new value gets added to the window current sum, because that's correct. The window is expanding. The current sum must accommodate for it. We remove the contribution of the value of the left pointer before we increase the left pointer. This is very, very interesting and important. You notice what I meant here is that first I have removed the value, the contribution of the left pointer, and then I have increased this because I want to make sure the correct value gets removed, right? So that's important. This sequencing is very important. In fact, we remove. Okay, so the while loop does not terminate when the first instance of right pointer reaching the end of the list. We saw this because for several iterations it's possible that the left pointer is moving, as we just saw. We make sure that if left is equal to right, we only expand the window. But in this situation, the min still gets recorded because again, notice if my current sum is less than equal to t or my left is equal to right? So if current sum is equal to t, anyway I'll come in here, I'll record the window, but even if left is equal to right, we will in fact come and check this still, right? So this condition is important, otherwise the code won't work correctly, right? So think through this. Very, very interesting, this piece of code, how we have taken the illustration and literally converted that into a while loop. Just seeing, making sure the pointer, either this moves, either left moves or the right moves. Very happy to discuss, but do look at it carefully. Now, this is always our style at YByte. Go through code carefully, systematically, in a step-by-step manner, and analyze it in detail. Look at our website, www.ybyte.in, because that is how we learn programming. Take care and enjoy.